I think it was 2 months ago, I needed to write a crawler, a script that was getting data from a website and importing that into FileMaker database for later processing. And all the data had all these HTML entities in the file. So I needed some way how to decode it to the real characters so that it's readable. But I didn't want to decode the characters using some system level script before importing to FileMaker, because then I would run into risk that some of these characters will be recognized by FileMaker as data separators. So I wanted to first import the data to FileMaker and then decode it. As you can see here, I am talking about a file that has over 15,000 lines. So it really does matter how long it takes to decode one record here. I found Fabrice Norman's custom function that was pretty good in decoding the special characters, but it was doing one thing that was not very good for speed. As you can see, these are all the HTML entities, the named HTML entities that I needed to decode. And the original custom function was a recursive custom function that was running multiple substitutions on the source text, and it was doing that for every single recursion. So when the original text had like 1,000 HTML entities in it, it was running the substitution 1,000 times, even though the named entities needed to be replaced only once. So the first optimization I did, and I wrote about it in my blog, was that I made a small modification here that when running for the first time sets this variable, and when entering another instance of the same function using recursion, checks that variable and skips the substitution. So if I am deeper in the recursion, I simply return text, and only for the first time I use the substitute. That makes it faster in the recursions, but there is still a lot of time this function takes to actually process the substitution because there are so many HTML entities. And what I discovered was that here, when trying to decode the whole file with those 15,000 lines in one field, it became much faster. But when I wanted to decode individual records, it wasn't faster. Almost it was the same. It took about half an hour to import all those records and process them. So I was wondering why, and the reason was that for most of the records the function didn't need any recursion, because there were only named HTML entities, or at most one evaluated the number encoded entity. So I really needed to speed up the substitution itself. And then I thought, well, and this is the basic rule what you have to follow when you want to optimize code. You have to think what's happening behind the scenes. So what do you think that's happening when you use substitute? FileMaker has to go through all the string and find all occurrences of the original string and replace them with the new string. Even if there is no occurrence, it has to scan the whole text to find if there is some. So if you have nested substitutions and there are 250 HTML entities, then FileMaker is doing this 250 times. But most strings do not have so many HTML entities in them. And since every named HTML entity is encoded as ampersand and some name in some abbreviation using just English characters, I thought about, well, what if I split all the whole set of HTML entities to maximum of 26 by alphabet, and try to first check if there is any occurrence of &a in the string, and if there is no &a in the string, there is no need to do any substitutions with the HTML entity starting as with &a. So the modification I did with this custom function, I have actually a new version here, was that I added this calculation at the beginning of each group. So if there is no &a in the string, I simply skip all these substitutions. If there is no occurrence of &b, I skip these substitutions, and so on. When doing substitute as a one function call, it takes much less time to process one character or one occurrence than having to call this function for every single occurrence. So I can imagine that if I do this check for every single HTML entity, it may be slower than using the substitute. But it may be even useful to like split this large group to some subgroups or something like that. You get the idea. What's the key? So let me show you what's the difference between these two versions. I have 3 testing records here. This record has a subset, small part of the text here with 3 almost 4,000 characters. The second record here has the whole file in it, and then there is a third record which has which is already decoded. So this third record doesn't have any HTML entity in it. So let me start with this third one. I'll try to decode this one record with the original function and with the optimized function. And let's see what's the difference. So the original one took 93 microseconds and the optimized 43 microseconds. So it's about half the time. Then let's try the first one with the 4 kilobytes. The first version and then the second version. It's quite fast, so it's not noticeable when you try it on a single record, but when you run it through 15,000 records, it's much different. So here I can see that there is a difference between 27 milliseconds and 20 milliseconds. So you can see that if there are HTML entities, the difference is not so high. If there are no HTML entities, then the difference is huge. It's because in the optimized version I simply skip substitutions if there is nothing to substitute. And that's the key. It's faster to check if there is at least one occurrence of &a before doing the substitution, even though that it's some extra coding and extra checking.